we're going to talk about the rational zero theorem. Okay, the rational zero theorem basically states if you have a polynomial with integer coefficients, that's what integral means. It means whole number coefficients, no decimals, no fractions. Then every rational zero of the polynomial is of the form p divided by q. Okay, now here's where p is. P is actually a factor of the constant term, and q is a factor of the leading coefficient. So in the example, they give me a polynomial here. Let f of x equals 6x to the fourth plus 22x cubed plus 11x squared minus 80x minus 40. Okay, all the possible rational zeros will be negative 40, because that's the constant term, divided by positive 6. Okay? And so we're going to look at that, and we're going to call those the PRZs, for possible rational zero. Okay, so let's go and look at this example. It says list all of the possible rational zeros of each function. Okay. So here we go. We have the PRZs. The PRZs we can find by taking the factors of the constant term divided by the factors of the leading term. Okay, so I'm going to take factors of constant term, okay, divided by the factors of the leading term. Factors of the constant term divided by factors of the leading term. So the constant term in this problem is what? 16. So I need to go ahead and list all of the factors of 16. Now, one of the things about the factors is that it can also be a positive or a negative. Okay. So first of all, I have 1. That's a factor of 16. So I'm going to put plus or minus 1. What's another factor of 16? 2, right? We like to go in order. Okay, what's another factor of 16? 4. Another factor? And another factor is 16. So those are all the factors of 16. Yes, you have to do the plus or minus. Now we're going to do the factors of the leading term, which in this case the leading term is 4. So you just said 1, 2, 4. So now what I need to do is divide all those. Now there's an easy way to divide, so before you all panic and think, oh my gosh, this is going to be tough. Okay, this is how we're going to start. First of all, I'm going to divide all of those by 1. So would you agree if I divide all of the numerator ones by 1, I'm just going to get 1, 2, 4, 8, 16? Okay, so we're going to go ahead and write those down first. 1, 2, 4, 8, 16. Okay. Now we're going to divide by 2. So if I take 1 and divide it by 2, I get 1/2. All right, what happens if I take 2 and divide it by 2? What do I get if I take 2 divided by 2? 1, and I already have 1, so I don't need to list it again. 4 divided by 2, already have it. 8 divided by 2, already have it. 16 divided by 2, already have it. So there, you're done with dividing by 2. Let's look at the next one. I need to divide now by 4. Okay, so first of all, I'm going to start with 1. So if I divide by 4, I get 1/4. What's 2 divided by 4? 1/2, already have it. 4 divided by 4, already got it. 8 divided by 4, already got it. 16 divided by 4, already have it. So here are all of your PRZs. Okay, now when it says a possible rational zero, that means possibly any of those could be zeros to the function. Possibly.
I have a feeling this might get hard.
So then now let's go ahead and look at this next one. Okay, so we're going to find the PRZs. Okay, so I'll let you go ahead and write the function down. Okay, so now we're looking for the factors of what? 12. So let's start. I have 1. What else? 2, 3, 4, 6, 12. So far so good. So now we're going to do the factors of what? 1, because that's the number here. What are the factors of 1? Plus or minus 1, right? So really, whenever you have that, we always like these because your answer is just going to be whatever the numerator was. Okay, that was kind of a nicer one. So any questions about finding the possible rational zeros? Okay, let's go ahead and we'll look at one more, and then we probably won't look at the one on the bottom here because I think we've pretty much probably gotten it down. Okay. So let's look at this next one here. So what will go on my numerator? Plus or minus 1, 2, 5, and 10. And just let's remember where that came from. That's the factors of my constant term, which is 10. I'm going to divide that by the factors of what? 3. So what are the factors of 3? 1 and 3. So now we need to divide. First of all, when I divide by 1, that basically means everything that's already written in the numerator will be one of the answers. Okay. So now I'm going to divide each of the terms by 3. So let's start. 1 divided by 3. 1/3. 2 divided by 3. 2/3. 5 divided by 3. 5/3. And 10 divided by 3. 10/3. So actually, every one of those was a new one. They didn't repeat. And that will be your final answer. Do you think we need to look at that bottom one, or do you think you've got it down? You got it? Okay, let's go ahead and look at the next question then. Now this one says find all the zeros. This doesn't say find all the possible zeros, but that's where we're going to start. Okay. So the first step when it says find all the zeros, you're going to start with the possible rational zeros. We're going to list the PRZs. So let's go ahead and start. So the factors of the constant term will be what? 1 and 5. What are the factors of the leading term? 1 and 3. So my possible rational zeros will be 1 and 5. And then what else did you say? 1/3 and 5/3. So I have a total of 8 possible zeros. I need to find all the zeros. Remember, since this is a degree 3, how many zeros can I have?
3.
3 total. So this is the thing. We need to find one of these to work. Once we find one of them to work, we can get it down to a degree 2, which means we can use the quadratic formula or factor. So let's start with the number 1. Okay, so what I need to do is plug this in. The easy way to plug it in is to use synthetic substitution. That's probably one of the fastest ways. Unless you just want to plug it in directly, you can do that as well. I just like synthetic substitution because I can generally do that a little faster. Okay, so remember synthetic substitution, what do? Bring the 3 down. So then I take 3 times 1, which is 3. What do I get now? 1. This isn't going to work. -7, -2. So 1 doesn't work. Yep. So now another one to try. Let's just try -1. So you have 3, -2, -8, 5. So what do you get? 3, -3, -5, 5, -3, 3, 8. -1 doesn't work. Okay, so then we have 5. Let's try 5. Oops. Well, we'll use a real short line there. So then we get 3, what is that, 15, 13, 65. We can already see that one's not going to work. Okay, because you're going to get some big numbers. So 5's out. What would be another one to try? -5. Let's see if -5 works.
This is a really long process.
Yep.
Is this your favorite thing to teach?
So let's go ahead and see if -5 works. So 3, -5, -7, 35.
-15.
What -15? Oh, -15, sorry. So it'd be -17. It's still not going to work. That's going to be a worse one, 85. Okay. All right, so now we're going to divide and conquer. This table has 1/3, -1/3, 5/3, negative. You guys are in with the -5/3. Okay? So you just plug that one I gave you in. You guys have 1/3, -1/3, 5/3, -5/3. Let's see if we can have one of those that works.
Are we allowed to use our calculator?
Yes, you can use your calculators. So I'm looking for one of those remaining 4
Me 3.
that works. Okay? One of those remaining 4 that works. What works?
5/3.
Bingo, 5/3. So here we go, 5/3. Let's go ahead and see what you got. You had 3, -2, -8, and 5. So you should have brought down the 3 times 5/3 should have been 5. Bring down a 3 times 5/3 should have been 5. Bring down a -3 times 5/3 should have been -5, and it does work. Now the benefit of using synthetic substitution is that now, since I cancel off my remainder, this is actually 3x squared plus 3x minus 3. That's why we did the synthetic substitution, because then now I can look at this and see if I can factor. Can I factor that? Nope. So then what's my next option? Quadratic formula. So quadratic formula, you're going to do -b plus or minus the square root. B squared, which will be what? 9 minus 4 AC all over 2A. So I end up having -3 plus or minus. This is going to be 9 minus what? -36. So really it'll be the square root of 45 divided by 2.
2 times 3.
What do you mean 2 times 3?
Is
Oh,
that
2 times 3. Yep, you're right. Sorry, I forgot the 3. So there. Yep, so it should be 6. So make sure you get that. Yes, I made a mistake there. So 6. Final step is you have to break 45 down. $45 you know is 9 and 5. 3 and 3. So really I get negative 3 plus or minus 3 root 5 all over 6. And then you can reduce. Oh no. So what'll that reduce to? Negative 1 plus or minus root 5 over what? Over 2. And then my other 0 from before was 5/3. So those are your zeros.
Fun.
Okay?
How long did that take us?
A while. So this is what I'm going to do. I'm going to go ahead and go to your assignment. Now I need you to turn in your book to page 370. Okay? Page 370. 10 through 18, the evens. If I remember right, those are the PRZs. Right?
The first things we looked at?
Yep, the first things we looked at. So those shouldn't take you that long. Then you have number 22, which if you look at 22, it says find all the rational zeros of the function. Okay, then I need you to do 28 through 32, the evens. That's 3 of them, just like we finished up with. Okay, so, ready to go?